So what I would like you to do is look at this getting ready question right here, and I want you to answer the following questions. Could orange B be larger than orange A? Why or why not? Can you predict the radius of the oranges from the given information that you have here? Why or why not? And then what information would you need to determine the radii of each of the oranges? So I want you to really think outside the box. Don't go for the immediate obvious. So pause the video and try to answer those questions. All right, so first question, could orange B be larger than orange A? Why or why not? And the answer is yes. The slice from orange B could indeed be larger than orange A because this could be sliced from the top of an orange, not through the center. So don't assume that this slice came from the center. I mean, that's what I would assume at the very beginning of looking at it. So you don't know if these three slices are directly from the center, which would help you find the radius. Second question I asked you, can you predict the radius of the oranges from the given information? And based upon what I just said, no, you do not know where the slices came from in that orange. You don't know if they're straight in the very center where a hemisphere would be, or did it come from the top? Did it come from a side? You don't know. And then the last question I asked you, what additional information would you need to determine the radii of the oranges? You would need to know where the slice was cut. If this slice was indeed cut from the center of the radius, or the center of the orange, then your radius would be half of this 9. But if this cut was not from the center of the orange, then that is definitely not the radius, and you would have to have a cut going through the center of the orange. Okay, so let's look at the vocabulary that we have here. So we're going to go through these vocabularies right here, but I'm going to make this really big so I can write on it. Whoops. I'm going to make that really big so I can write on it. And I'm going to try to make it straight. All right, so this is pointing to this line right here, which is going from top to bottom through the center of that sphere. So this is known as the diameter. And then this is halfway from the edge of the sphere to the center. So this is, of course, your radius. So those two terms you're familiar with. And then this, as you suspect, right here, that's the center of the sphere. And then finally, this one's pointing to this circle all the way around. And that is known as the great circle. So let me come up with, I'm trying to change my color. Oh, let me change my color. Alrighty, well, we're going to write great circle. All right, so then I'm going to make it smaller again so we can finish talking about this stuff. All right, so surface area of a sphere. A baseball is a great way to actually see what you would consider as the net of a sphere, because if you take off the stitchings, you have this kind of shape here. So it's kind of a weird kind of net looking thing, but I just thought that was interesting to show you what the surface area of a sphere looks like if you tear it apart. So let's talk about the formula for surface area. So your formula for surface area is going to be surface area equals 4 pi r squared. Right, so it looks like the area of a circle, but then we've got 4, because you kind of essentially end up with 4 circles here. It's not 4 circles exactly, but to the powers that be, 4 pi r squared. Then we're going to have to know the volume of a sphere, and so I don't know why, But if the volume of a sphere is a space that occupies a sphere, we're going to put volume of a sphere here. So V equals, so that's going to be 4/3 pi r cubed, which kind of makes sense. Volume should be cubic, surface area should be squared, and then we're going to spend some time finding some of these surface areas. So I'm going to run through the first one. So we do need the radius for both formulas. So no matter what you're given, you're going to have to find the radius. In this first example, you've been given the radius. In this example, you've been given a diameter, so you'll have to cut this one in half. So I'm going to do the first one with you and let you do this one on your own. So again, we're going to be formula driven. Surface area is equal to 4 pi r squared. So we're going to find it in terms of pi. I think we'll just find it in terms of pi today. And I'm going to take this 2.8 and put it here. And so if 1 squared, let's not forget to square it. So we're going to take the 2.8 and square it first. So 2.8 squared is 7.84, and then we're going to multiply that to 4. And so I end up with surface area equaling 31.36 pi, and then that's meters squared. So then I would like you to pause the video, and I would like you to find the surface area of 1B. All right, so hopefully you paused the video, but I'm just going to go through here and use formula surface area equals 4 pi r squared and this right here is equal to the diameter, so that means the radius is half of that, so the radius is 12 millimeters. So we're going to put 12 in here. 12 squared is 144, and then I'm going to multiply that to 4, and so I get total surface area of 576 pi millimeters squared. So formula's not so bad. Let's look at the next page. Oops. All right, let me make this bigger. All right, so in this particular question, I would like you to read it and determine what it's asking. So the diameter of a standard basketball is 9.5 inches. If the basketballs are covered in rubber, which they are, what is the minimum amount of rubber needed to manufacture a set of 4 basketballs? So are they asking you for surface area, or are they asking you for volume? Since we're just covering the outside, we're asking for surface area. So I want you to find the surface area of 1 basketball. Note that they gave you the diameter, so we really want radius. And then we need 4 of them. So go ahead and pause the video, complete the problem, and show all your work, formula driven, not scratch work, and then restart the video. Okay, so if we've got a diameter that's 9.5 inches, that means that our radius is half of that, and half of 9.5, oops, half of 9.5 is 4.75. And then that's in inches. And so if I want the surface area of 1 basketball, I'm going to do 4 pi r squared. So 4, and I'm putting in here the 4.75. Now if I square 4.75, I get 22.5625, and I'm going to multiply that by 4. And so my total surface area for 1 basketball is 90.25 pi, and that's inches squared. But we want 4 basketballs. So then we're going to take that 90.25 pi and we're going to multiply it by 4. So then times 4 again. And so, therefore, the minimum whoops, I have no idea where that came from. The minimum amount of rubber would be 361 pi, and then that's inches squared. All right, so the next question says, given the circumference is 9.25 inches, find the surface area. Well, if they're giving you the circumference, that's really the great circle. It's an R. So that's really the great circle. So we're going to take this value, and because it's circumference would be 2 pi r, and I'm using 2 pi r rather than pi d because I want the radius. So all I did was take circumference, which is 2 pi r, and I replaced c with that, and the right side is still 9.25. If I want to solve for r, I have to undo multiplying by the 2 and the pi. So we're going to divide both sides by 2 pi. And because we want surface area and not just the radius, I am going to round my radius to 5 decimal places because I've got pi in here. And I'm going to have to divide 9.25 by pi. So I'm going to take 9.25 on my calculator. I'm going to divide it by 2, which gives me 4.625. And then I'm going to divide that by pi, which gives me approximately 1.47218. So you want to go out to 5 decimal places because we're going to use this to actually figure out what we want to do. So this was step 1. Now step 2, now that I have my radius, I can find my surface area. So surface area is 4 pi r squared. So we have 4 pi. Whoops, I want a much longer, want a much bigger place to put in my rounded amount. So 1.47218. Now, mind you, I still have that long decimal in my calculator, so that's the decimal I'm actually going to use. And I'm going to have my answer in terms of pi. But I'm keeping that long decimal in my calculator. I'm going to square it, which gives me about 2.17. And I'm going to multiply that by 4. And then I get surface area is equal to 8 point, and I'm going to round to 2 decimal places, so it's 8.669. So since I'm rounding to 2 decimal places, behind my 6, my second 6 is a 9, so I'm going to bump that 6 up to a 7, which means this is now squiggle equals, and then pi, and then inches squared. So it's 8.67 pi inches squared. Let's see if I can make the squiggly equals prettier. Squiggle. There we go. That's much better. Okay. Now, let's talk about volume. I already gave you the formula earlier. So that formula is going to be 4/3 pi, but r cubed. and volume is the space a sphere occupies. So let's look at 2a. We're going to find the volume of this sphere. So I just want you to go ahead. I think that you're perfectly capable of using that formula. So go ahead and pause the video. You have the information you need because this right here is your radius. So pause the video and just apply the volume formula, bearing in mind that the pi r cubed part is in the numerator. So basically you're going to take the surface area, which is 4 pi r squared, but in this case we're going to use 4 pi r cubed and divide it by 3. So in other words, for volume, I would look at it this way. Instead of 4/3, it's 4 pi r cubed. Consider all that divided by 3. All right, so now pause the video and substitute in for r. Leave your answer in terms of pi. All right, so I'm going to take 4 pi, and then I'm going to input my 7, cube it, and divide by 3. So the very first thing I'm going to do is cube my 7. So I'm going to take 7, raise it with my caret on my calculator to the third. I get 343. I'm going to multiply that by 4, and I get 1,372. And then I'm going to divide by 3, which is a decimal that's going to need to be rounded. So my volume is going to be approximately 457.33 pi, and then it's inches cubed, because remember volume is to the third. All right. And then our last problem, I think that's our last problem. Yep, our last problem, we need to find the surface area and the volume of the following figure. So remember, surface area is really touchy. You have to pay attention to, you can't just take the surface area of, and this is a hemisphere, so it's half a sphere. So whatever our surface area formula is, 4 pi r squared, we'll take half of that, which is 2 pi r squared. But, and in this case, that works out well because we're really only having half of it. But with this cylinder right here, remember it's normally with a cylinder, it's 2 big B plus LA. And we talked about that big B is pi r squared and that the LA is 2 pi RH. So we've gone through that in the past, but the difference is you only have one big base showing. That hemisphere is covering up this top big base. So for our surface area formula for the hemisphere, we're doing half of the 4 pi r squared, okay, plus we're only doing one big B instead of 2 big B's for the cylinder, plus the LA. So let's write this out a little bit more. So half of 4 is going to be 2, so we have 2 pi r squared. Big B is pi r squared. And then your LA is pi, 2 pi RH. Now you could combine these two and make it 3 pi r squares because they both have a pi r squared, but I'm going to put them in there separately. All right, we know that this is the height, not of the cylinder, but it's the height of from top to bottom. So we have to find the height of the cylinder. So to find the height of the cylinder, I'm going to erase this. So let's see, height of the cylinder, because I only want height of the cylinder. That's what this height refers to here, is just of the cylinder. So if all the way across here is 22, then all the way, then this is just halfway. From the center up to here, that's halfway, so that's the radius. So if this is the diameter, the radius would be 11. So to get the height, I need to take this 11 off of the 45. So I need to take 45 and subtract 11 from it. And so the height of the cylinder is equal to 34 feet. The radius is half of the 22, which is 11 feet. So now let's put these together into our formula. So we have 2 pi, big parentheses squared, plus pi, big parentheses squared, plus 2 pi, parentheses, parentheses. So then I'm going to put in for the radius 11 here and 11 here and 11 here. And then the height is going to be the 34 feet we found earlier. Okay, so 11 squared is 121. 121 times 2 is going to be 242. So for this first part, I get 242 pi plus 11 squared is 121 pi plus 2 times 11 is 22, and they're going to take 22 times 34. So 22 times 34 is 748 pi. Then we just have to add all these together. So our total surface area is the 748 plus the 121 plus the 242 for a grand total of 1,111 pi feet squared. Okay, so that's our surface area, and that is part 1. They wanted surface area, and then they want the volume. So let's do part 2, volume. So volume should be a little bit easier because the volume for the cylinder is going to be the same as normal volume. It's going to be area of the big B times H, right? That's cylinders. So let's start with that. So volume for the cylinder is big B H. We'll come up with that in a minute. But then we only want half of the volume for a sphere. So we want to add to that half of 4 pi r cubed over 3. So can't this 2 cancel into the 4 twice? So 2 goes in here once and 2 goes in here twice. And then I'm going to replace the values for B and H. So our volume really is going to end up being for our big B, which is our circular bottom here, this circular bottom, that is pi r squared times the height of the cylinder, which we already have both of those, plus 2 pi radius, 2 pi radius cubed divided by 3. Okay, so here we go. Pi big parentheses squared times H plus 2 pi big parentheses cubed divide by 3. So let's plug in our values. So our radius is 11, our height is 34, and then our radius is 11, goes over here as well. So let me move this up a little bit. So 11 squared is 121 times the 34. All right, so for our first part, we get 4,114 pi plus, then over here we're going to cube the 11, so 11 to the third is 1,331, then times 2 makes that 2,662, and then divided by 3 gives us, and this is going to be an approximate, 887.33, and you could go out to 5 places, but it's just 33 repeating, and then that's pi. And then I'm going to add to that, and I have the big long decimal. I have this big long decimal in my calculator. I'm going to add the 4114 to that. And I get a total volume of, and it's approximately because I rounded on this second calculation here. So total volume should be 5,001.33 pi. And because it's volume, it is feet cubed. So that's it. So good luck with your homework. Please let me know if you have any questions, and text me if you do.